Welcome to Real Learning Center. So we are working on how to create XT and VT graphs. In the first class actually we learned how to plot graphs for various equations. Then we went and understood what is the meaning of XT graph and VT graph and also acceleration graphs, all that we understood. Now in this class we go a little bit further, okay, and say how do we analyze this XT and VT graphs? By looking at them, can we, for example, look at an XT graph and write the VT graph, etc. So that kind of analysis will take a little bit further in this session. Okay, so let's start. Now, first of all, I want to establish a graphical relationship between X, V, and A. So how do we do that? Let's say we start with a very simple X, V, and A empty sheets here. And I start with V. Okay, so let's say I have a V, a simple VT graph, which says that velocity is increasing gradually. Okay, in a linear way. Now velocity is increasing linear ways. Can I now draw by just looking at it an XT graph and an acceleration time graph? Can I draw? Okay, that is what I will first try. So what I will try is first I will mark some 2 points. Okay, so these 2 points are actually I will call A and B in time. In time they are A and B. And so whenever I will talk about, for example, XT graph, we should be able to say, okay, between the interval A and B, how much has it moved? What is the displacement X in the interval A and B? That is what we are going to plot on the top. Okay, so by that time we plot at point B, we should show the total displacement from A to B. And in actually somewhere in the middle the displacement will be corresponding to that time. So like that we should be able to plot the XT graph. And AT graph we have to show what is the acceleration at each point in time. Now first of all let us do AT graph, that is simpler. Okay, we have already established in the last session that acceleration is nothing but the slope of velocity, and velocity is nothing but the slope of displacement. So we just have to find the slope of this at every point to be able to draw the acceleration graph. So how do we do that? So let's draw these lines, okay, and you can see that we can draw a small triangle here, which is the DCE, the triangle DCE. So triangle DCE is giving us the slope in terms of the CE by DE. Okay, the vertical by horizontal is going to give us the slope, and that slope I would claim that is constant, in the sense that if you go along in the T, that side or this side, the slope remains same. That means that triangle, okay, same triangle, you can move it. Like for example, you can just move the triangle to the up and you can see that it is on the same line. So the slope wherever you go is going to be basically same. So if the slope is same, what does it mean? That means acceleration is not changing. From A to B, everywhere it is the same acceleration. And what is its value? Its value is CE by DE, whatever the height of the CE. You measure it and times DE you measure it and divide it, you will get the slope. I am going to take that value and mark it on the A. A is the vertical axis. On that I mark this, and that point I get, I am going to draw a horizontal line because it's not changing, same value every point in time. So constant acceleration, that is our AT graph. We are able to draw the AT graph using the XT graph. Now how do we draw the XT graph using the same VT graph? That is the question. Okay, so draw the XT graph from the VT graph. We have to do one more thing. Okay, the fundamental idea is that the XT graph, after you draw, whatever may be the slope of that at every point, that would be the V. Okay, so the way to find out that is we should take the area under that line. Okay, so I am going to basically take the area under the line. Okay, you see here the area under the line DC AB. Okay, ABECD, that trapezium, that area if you take, okay, that area will give us the displacement during the AB time frame. Okay, that means during AB, okay, the area, the displacement what we get is nothing but this area. You compute the area, and that is what you mark there. That is the displacement during that time. And we know that as it is growing from left to right, when you go, velocity is increasing. Velocity is increasing means what? That means it covers more and more distance as you go more farther in time. Okay. So if you draw a straight line in the xt graph, that won't work. It covers exactly same amount of distance for same amount of time. So what you should do, you should draw a curve. We talked about a square curve. Okay, t square. We know s is equal to ut plus half a t square. That square curve is what we are drawing. Okay, so that curve tells us that as you grow further, okay, so let us say if we take a small duration of time towards the right side, you can see that that time corresponds to a bigger jump in the x. But if you are on the left side, okay, small duration of time corresponds to a very small jump in the x. So that means that it is faster later than earlier. Okay, that is how we are able to draw xt graph. So this is basically the relationship between xt graph, vt graph and acceleration graph. So given vt graph, we now were able to draw the at graph and also the xt graph. So if suppose you are given an at graph, can you draw the xt graph? Can you draw the vt graph? From a to v, how do we go? From a to v, we go in the same way as we went from v to x. That means we need to take actually the area under the A line. Okay, so you go there and make an area there on the A line. So that area, okay, what we call basically PQSR, that area is nothing but, okay, the velocity at the point at which, the later point, that is the point at which AB, B point. Okay, so that area, if you see, we can actually compute, and that would be equal to that small jump from D to C. CE height will be equal to that area, and that is quite obvious. You can see the height of this rectangle that you see is CE by DE, and the bottom of the rectangle is nothing but the length of the AB, which is same as DE. Okay, now the area of this rectangle, if you see, is nothing but CE by DE into DE, and DE gets cancelled and you get only CE, and that is what is that CE height. So you got that there. So whenever you go from acceleration to velocity, you have to deal with areas. Okay, whenever you go from velocity to x, you again deal with areas. However, if you go the other way around, x to v and v to a, you have to deal with slopes. So that is what we have shown you in this graphical relationship between x, v and a. Okay. So now let's move forward and understand a little more of these values of x and v and their slopes, etc. When they have negative values of x and v, what do they mean? Okay. I am going to take a very simple scenario. A cyclist standing at A, he is going to go from A to B and come back to C with a constant velocity. Okay, let's see what he will do. He will go from A, okay, and he will travel up to B, turn around for small duration of time, and then comes back to C. Okay. Now, how do we actually plot this as in terms of xt graph and vt graph? So, see what happens from A to B. A to B, okay, the x, the displacement, is positively varying and increasing, okay, in a gradual way, in a linear way, at a constant velocity. So we can say during that time, xt graph is showing like this and vt graph is showing like this. This says that it is constant velocity, and this says that displacement is basically becoming more and more as the time passes in a linear way. So that is the xt, and this is the vt. So this is further duration from A to B. At B, what happened? The driver changed over. in the sense that he turned around for a small duration of time. While he turned around, actually, really speaking, what really happened was, he doesn't stop at B like instantly. He slightly slows down and stops. Then he turns around and then speeds up and starts going. Okay. So that means the velocity actually decreases, becomes negative, increases. So decreases to go to 0, becomes negative, increases, in the negative direction it has increased. So velocity now is basically increasing to the negative direction up to some point where it starts basically going now. So he will actually start now moving. So when he starts moving from B to A, you can clearly see that velocity is constant, but this time the velocity is a negative constant. You can see it's a negative constant because it is moving in the opposite direction. And x value is from B to A. As long as he is moving from B to A, x value is still positive, but displacement is coming down, coming down, coming down. When he reaches A, displacement becomes 0, and then he keeps moving, so his displacement becomes negative. By the time he reaches C, the displacement is completely negative. So this is how xt and vt graphs look when you actually take some of the negative values of x and y. Once you understand this, now we'll go forward and understand what are the positive values and negative values of A. What do they mean? Let's take this simple scenario of a ball that is bouncing from the ground. So this is ground where I have put B, point B, which is 0 height. Okay, and A is the point at which height h. From there I am dropping the ball. So it's actually going to go down and come back to the height, some other height C. We call it as height h1. Okay, so A to B and back to C. What happens with the velocity and acceleration and the position, that we will see. Okay, so when it is at A, we know height is h. Okay, and then gradually the height keeps reducing up to it becomes 0. That much we know. Okay, so however, we know that the velocity with which it is coming down is not constant. Earth is pulling it, and hence because of the Earth's gravitation, there is an acceleration of the ball due to gravity. So velocity is continuously increasing. Okay. Now what we are going to do is we are going to take some sign conventions, in the sense that the ground is, I will call 0. Okay. If you go away from the ground, I call positive. Okay. If you come towards the ground, basically, then the direction of the velocity is negative. Okay. This way is positive, this way is negative. That's what I am going to call. So it's just a convention. So now x also, this way positive movement. So now what we will do is we will find out what is the value of velocity. Initially velocity is 0, but velocity will keep on increasing in the negative direction because it is going away. Okay, so we are going to draw that now. So you can see the velocity is initially 0 and increasing in the negative direction. Okay, till it reaches the point B where it hits the ground. During that time what happens? Acceleration is constant because velocity is simply increasing, okay, in the negative direction, though acceleration is constant and also negative because we are taking acceleration also in the same direction of velocity. So it is basically negative towards the ground. Now after it hits the ground, I am going to basically take the velocity to change its direction. So it was earlier certain velocity, now it changed the velocity to the positive direction. Okay. Now then onwards the velocity will keep on reducing from the positive direction like this. You can see velocity is it has moved to suddenly positive and then start moving down. Okay. At that instant basically there was a small glitch of changeover of this acceleration, but acceleration remained in the same direction. Okay. Acceleration always pulls down, so it is still continued. So only there was a slight acceleration towards up, which I cannot show. That instant it has happened, so I am just showing one single line. Now while going up, now what is happening to the position? Position actually is also, our displacement also is becoming positive more and more. Initially it is higher velocity, so it is taking a steeper curve. Afterwards it becomes slightly flatter and becomes 0 when the ball stops. Okay, so velocity of at that point, at the point basically when it reaches C, the velocity becomes 0. You can see it becomes 0, and that means that becomes horizontal almost, that curve. So that is how you understand the value of negative. See, negative acceleration is happening in both cases from A to B, okay, and B to C. In both cases it is negative acceleration. But you can see here that in the first case the curve is like this, in the second case the curve is like this, because velocity is initially negative and then it is later positive. So this is how you can actually understand the negative acceleration value. What is the meaning of negative acceleration? You understand from this. Basically it is retards. When it is going up, it slows down. So acceleration always is in the direction. See, look at this. In the case of the first part of A to B, okay, velocity is in this direction, up to down. Acceleration also is in up to down direction. Okay, hence it is accelerating. Velocity is increasing. If velocity and acceleration are in the same direction, it makes the velocity increase. Now in the second part, velocity is in the opposite direction, going up, but acceleration is still in the going down direction, and because of that, acceleration and velocity have opposite directions. When it is opposite direction, ball is slowing down. So whenever velocity and acceleration are in the opposite direction, the object slows down. Okay. That is what we understand from this. Okay. So now we will see, given xt graph, can we draw a vt graph? Can we draw a vt graph given an xt graph? There is an xt graph that is given. Okay, in the sense that x is changing like this, and then x is constant, then x is decreasing in a curve way, and then it is decreasing again in a straight line. So such a scenario is happening. Now can we actually draw a vt graph for that? So for that question, here is the answer. So let's start with the first one. First one is, it is going up like this. So what is the meaning of that? Here you see the slope is positive. Yeah, slope is positive, which means in this way. Okay, but initially it is steeper and gradually it is initially it is less steeper and gradually it is becoming more steeper. Hence, slope is positive and increasing in a linear way. So we can draw that, okay, for the velocity curve. So first we will actually name all these points and draw one line down like this, just to show the time where the things happen. Okay. So the first one, point A, if you see, from initial point to that A point, it is actually going like this. That means the slope is increasing and positive. Okay. Now from A to B, slope is 0, isn't it? From A to B, slope is 0. So we'll just draw a slope which is 0 from A to B. Okay. That is basically this slope from A to B. No movement, means velocity is 0, means the object is stationary at that point. Then from B to C, you can see very clearly the slope of that curve, the B to C curve, is negative because it is in this direction, but negatively initially it is steeper and then gradually less steeper. That means negatively high in the beginning and negatively low later. Okay. So what does it mean? It means that the slope actually is negative initially, very high, and that negative slope is decreasing like this. Okay. Negative, see, decreasing means what? Coming towards 0. So negative slope initially was higher and coming towards 0, it is decreasing. Okay. So in my view, the value of decreasing means coming towards 0. Okay. So it is decreasing slope. Now from C to D, you can very clearly see that it is a straight line, okay, and a constant slope. Constant slope, negative slope. Straight line, constant slope, negative slope. Okay, that we are going to draw here. Okay, so how much is that? That slope is this horizontal. Now I have put that slope to be slightly more in the negative sense than where it has reached, because at that point and C, you can see it has reached a slightly lower slope but when it starts going like this, the slope is slightly more. Okay, that is C to D. Now D to E, what will happen? You can very clearly see D to E, the slope is positive, means in this direction. Otherwise this is negative, this is positive. Slope is positive in this direction. So if the slope is positive in this direction, what can you do? You can actually go, you can calculate what is the slope and then plot it. Okay, positive slope from D to E. So for that, what do? We go to the positive slope at that instant and start plotting positive. Okay, and it is from up to F actually, the positive slope is. So that is basically our VT graph. So given an XT graph, we were able to draw a VT graph. Similarly, is it possible to draw a VT graph? Given a VT graph, can we draw an XT graph? We will also try that. Okay. So let us say this is our VT graph. I have drawn a VT graph on the top. So can we draw an XT graph for this? So it is not very straightforward. I have to think. So initially we are taking certain point at which the object is there. Let us say it's at 0. And from there, the object has to now start moving. Okay. So first anyway we will actually name the points and we'll also draw the lines, timelines. So once we do that, now I'm going to basically start from here. You see velocity is positive. Okay. That means above that line, that is positive. So during first OA scenario up to A, velocity is positive and constant. If positive and constant velocity is there, that means displacement will be linearly varying with a positive slope. So that is what is this, linearly varying with a positive slope. So A to B is velocity positive, okay, but decreasing. Just imagine some velocity is there already, okay, at that point at B, at the point A, okay, and from there the velocity is decreasing. That means slope has to be decreasing. So how does it happen? So it bends like this. That is, slope is decreasing. At point B, what happens? The slope is 0. So you can see very clearly at point B, okay, the curve has almost become horizontal and it is kind of 0 slope. And from B, again velocity actually is now going to be negative, okay, and not only negative, it is actually increasing in negativity. Okay. So that means now onwards on the XT graph, we should actually have x decreasing because velocity is negative. Okay. X decreasing. And when x is decreasing, but the slope is continuously increasing. So that means it is like this. Slope is increasing. Towards the later, it is more steeper. So once it reaches certain point there, then we are having a constant velocity. So constant velocity means what? Means a linear slope for this. So we can actually draw this one. This one actually continuously moving in the positive direction because positive slope, positive direction it is moving. Now from D to E, it is again moving in the same direction but with a higher velocity. Means slope is higher from D to E. So it is higher slope. From E to F, from now what happens E to F you can see. Okay, at E itself, suddenly the velocity actually became negative. Okay, that means it starts coming down. That is the meaning. Okay, and it has a certain velocity, and it is actually again changing, continuously increasing. So what will happen? So you can see the velocity is decreasing continuously. Means the slope is actually becoming like this, becoming lesser and lesser slope. And at the point of F, F to G, it is moving with zero velocity. Means it is just standing. Means we have a horizontal line from F to G. So this is how you can make actually an XT graph out of a VT graph. I am sure it is very confusing to start with. If you do more and more problems of this type, you will be able to draw XT graph looking at any VT graph. So we have kind of covered now how to plot graphs and also XT and VT graphs, and finally some analyzing of XT and VT graphs. So come back and let's go do more in kinematics and also the Newton's laws of motion, etc. Thank you.